So two special trig limits that you need to remember. I will not give them to you. You need to remember these two. The second one, B, I'm going to prove within this. The first one, A, I'm not going to prove it today. I might prove it another day, but I'm going to show you the graph of y it equals 1. So the limit as x goes to 0 of sine x over x, what's like the default method you will always want to try first before you use any of your fancy techniques to solve a limit? Sorry? What do you always try to do first? Yeah, just plug it in and see what happens. But if you put in 0, you're dividing by 0 here and it all blows up. It's actually 0 over 0. Okay? If you look at the graph, there's the graph of sine x over x. You can see as we go towards 0, the function goes towards 1. All right? It's undefined at 1. All right? If I put my cursor over top, I don't know if it's going to work. There. At 0, it's undefined. All right? But the limit doesn't care what is happening at that point. The limit describes what number are we getting close to. So that equals 1. And I'll prove the second one within these examples that we do. Okay, so remember trig from grade 12 math. What is really like doing proofs all about? What do you do a lot of when you're doing proofs? You're factoring, you're changing the way it looks, right? Trig limits are the same. Okay, so if we just start with like a straightforward one, A, the limit as x goes to 0 of tan x. Should always try to no. Try plugging it in first. All right? Because if you put in tan of 0, what's tan of 0? 0. That's a legitimate answer. So the answer is 0. The only time you have to manipulate it is if it's undefined, right? You're dividing by 0. So your default is always to try to plug stuff in. If I said the limit as x goes to pi of negative x cos of x, does cosine have any undefined points? No. Does x? So you just plug it in. So it's negative pi cos of pi. What's cosine of pi? Negative 1, right? Here's the cosine graph. Cosine of pi, which is 180, is negative 1. So this is just negative pi times negative 1, which is just pi. Okay, so same rules still apply. Plug it in if you can. That's the easiest way to do these. Okay. The limit as x goes to 0 of tan x over x. So, can you plug in 0? No, because then you're dividing by 0 and everything goes wonky. But as we remember from our Math 12 days, and we have purple, pink, green, blue sheets in front of us, what does tan equal? Wow, that was like in unison. It's like a cult. So we rewrite tan as sine of x over cos of x all over x. Is everybody good with that? Okay. These are fractions stacked upon fractions. What do you do when you're dividing fractions? Flip the bottom one and multiply. Now, the bottom fraction is like x over 1. So this becomes 1 over x. Like that. Okay? Still doesn't help us because we still have a 0 in the denominator. But we now have limit properties that we just learned. All right? So what I can do is rewrite this. I can go, oh, well, that's a special limit, right? So then I can go, okay, well, let's rewrite it as this. Is everybody okay with that? Did I change? Did I cheat? Did I do any illegal math maneuvers? Vina's like, yes. I just rewrote it. It doesn't matter if you go 2 times 3 times 4, or 4 times 3 times 2, or 4 times 2 times 3. Order of multiplication is irrelevant. Now, because I have our limit properties, I'll just scroll down. I'll scroll back down. But that says the multiplication one. If I have two functions being multiplied, I can rewrite them as individual limits of those functions. That allows me to rewrite this as the limit as x goes to 0, sine x over x times the limit as x goes to 0 of 1 over cos x. Yeah.
So I have a question. I don't know how did you change from sine x over cos x to sine x over x? Like,
Yeah, how are we allowed to do that? We're allowed to just swap.
Yeah, what's like you can do this. Watch. If I have 1/2 times 1/3 times 1/4, does it matter if I go 1/2 times 1/4 times 1/3 or 1/2 times what am I trying to do here? 1/3 times 1/2 times 1/4. Does the order of multiplication matter? I guess is what I'm saying. Well, okay, let's do it. What's 2 times 3? Times 4.
24.
Okay, what's 2 times 4? Times 3. 3 times 2. Times 4. Order of multiplication doesn't matter. We didn't change anything here. We just rearranged it. Okay, that's all we did. Are we okay with that? This is important because we're gonna do this a lot. Yeah.
You have to break it apart, like when you just use 1 times whatever cosine.
Can you what? Sorry.
Instead of like writing x is to 0 sine x over x times it, we just leave it like that.
You mean like this step and then do the answer? Yes. I'm just showing you this because we're using the property, and then this is something we know, and this is something we can
We're
do.
allowed to just swap them and then.
When you're multiplying, yes. Yeah. All right. So this is our special limit right up above. The limit as x goes to 0 of sine x over x. It equals 1. That's a given. You know that. So that equals 1. What is cosine of 0? It's 1, right? If you look at the graph, it's 1. So I can put in 1 over cos of 0, which is 1. So I get 1 times 1, which is 1. So the limit of that function is 1. Cosine of 0?
And you put it in back.
Are we okay?
Yeah.
We okay? Are we having fun? Okay. We're good? Okay. D. Let's do limit as x goes to 0 of x over sine of x. All right. Does that look like anything you know? It looks like that one, right? Our special limit thing. So, but we also have the properties of limits where it means I can take the exponent out. Okay? And manipulate this. And you can also do, so if I wanted to flip that, I could write it like this. Is that the same thing? It is, right? Because a negative exponent just means you flip it. But then I can use the properties of exponents to say, well, I can just do the inside function and then raise my answer to that exponent. And the inside function is a known limit. We know what it is. Limit as x goes to 0 of sine x over x is 1. So then I get 1 to the power of negative 1, which is just well, but this is why you can do that.
This is a question on the quiz. Would you expect us to do that?
No. I'll show you what this is like. If you see this, you should just know the answer is 1. That's what you should know. But this is the reason why it's 1. Okay? All right. Limit as x goes to 0 of x cosecant x secant x. All right, you've all got your sheets. Just like doing proofs, do we like cosecants and secants? Rewrite them as sine and cosine. Cosecant is 1 over sine of x, and secant is 1 over cosine. Okay, what do we want to do? To where? Can't pull functions out, you can only pull constants, like numbers. I would rewrite the x right there, right? So what your whole point here is to make it so that you can either sub in or you can use one of these two special limits, okay? So if I put the x right there, I rewrite it as this. Like that. Well, we just showed what's the limit of that as x goes to 0. And 1 over cos of 0 is? So the answer is, apparently all answers are 1. Do you want one that's not 1? Because cosine of 0 is 1. Yeah. What rule? Yeah? No, because of the graph. I can show you the proof tomorrow or something, but that's the graph of it. You can see you go to 1. All right. If you tried to put 0 in for all this, it would blow up because cosecant is undefined at 0. And if you tried to just punch it in your calculator, it wouldn't work. Yeah. All right. Oh, sorry, it should be cos squared, not sine squared. All right. The limit as s goes to pi over 2. If I say pi over 2, what do I mean? 90 degrees. What's cosine of 90? 0. What's sine of 90? So can I just plug it in? Sine of 90 is 1, right? So then you're going to get 1 minus 1, which is 0, and then everything blows up. So you have to rewrite it. What's cos squared? 1 minus sine squared. If you look on your Pythagorean identities part of the sheet, I have to bring it up here. This one. Cos squared, I move the sine squared over as 1 minus sine squared. That's on your sheet. So I got 1 minus sine squared over 1 minus sine of x. What are we doing now? Factor the top. What does it become? Yeah, it's a difference of squares. Those cancel. And you're left with the limit as x goes to pi over 2 of 1 plus sine of x. You can plug in sine of 90 into that, right? So you plug in pi over 2, and I get 1 plus sine of pi over 2, which is 1. You get 1 plus 1 is 2. Different number. We having fun? Okay. G. Hmm? Oh my gosh. You cannot take out the 5. You cannot touch the 5. But there's something you can do. So, well, hang on. Well, hang on. I'm not sure what you're saying, but one sec. Okay, you cannot touch this 5, and you can't plug in 0 because you're going to get 0 over 0 and everything goes crazy. So what you can do is you can make it look like an identity that we know, a limit identity. If this is 5x, you want the same in the denominator, okay? So I want a 5 there, but you can't just throw a 5 in. What can you do? 5 over 5, you can multiply by 1, 5 over 5, right? If I put a 5 there and a 5 there, really that's just 1. Correct? Okay. Now, we have a constant. The very first limit property I gave you said you can pull constants into and out of the limit, right? So I can go, okay, the top 5 I'm going to pull out. So now, stop. Sine 5x over 5x. Okay, everybody with me? Now, I'm going to show you why you can do this. You don't actually have to show this, though, okay? Then what I can do is I can go, okay, I got these 5s in front of the x's here. I'm going to sub them out, okay? I'm going to say a is equal to 5x. So I get so then it's going to become the lim, hang on with that for one sec, of a over a. Okay, I just said a is equal to 5x. That's all I said. As x goes to 0, what does a do? What does the graph of 5x equal to? What does the graph of 5x look like? It's a linear line through the origin, right? As x goes, if I said this is a is equal to 5x, as x goes to 0, the limit that they're asking us, what is 5x going towards? It's going towards 0, right? As x goes to 0, it goes to 0. Does that make sense? Yeah. Not said with a lot of confidence. So as x goes to 0, then a goes to 0 as well. That's the point here. Oh. This 5 you mean? I'll put it out there. There. Okay. Now, if I cover up that 5, what is this? That's 1, right? I just changed the variables, but it's the exact same thing. It's still this. I just changed all the variables. Okay? So it equals 1, but you have that 5. One sec, bro. You have the 5 in front. So the answer is 5 times 1, which is 5. So what's the shortcut? I don't like shortcuts, but what is it? Who sees it? If you start with this, you know the answer is going to be whatever this number is right here. Okay? But that's why you can do it. All right? It's not just magic that it's 5. Did you have a question? Why is it? Oh, I just wanted to get rid of this so it matched our. Why is it a going to 0? So I said, okay, a is equal to 5x. This is the graph of 5x. As x goes to 0 on that graph, okay, a is going to 0 as well.
Does that matter?
It matters mathematically, it matters because then you can do this substitution and get this identity. As x goes to 0, then the a value goes to 0, so I can rewrite the limit like that. For what you're going to be asked to do, it doesn't matter that much. All you really have to know how to do is go like this. Put a 5 and a 5. And then understand that that is going to be 1 as x goes to 0. All right, one more example and then we're done for the day. And we'll do practice tomorrow. GH. Last one. Here we go. Limit as x goes to pi over 4, 1 minus tan of x over sine x minus cos of x. What is pi over 4? 45. What's sine of 45? 1. Either right, 1 over root 2 or root 2 over 2. Either way. Right? Everybody agree with that? Okay, what's cosine of 45? 1 over root 2. It's the same thing. So you get 1 over root 2 minus 1 over root 2, which is going to be 0. So you can't sub it in. So what do you do? Get rid of tan. Write tan as sine over cos. Okay, what do you do now? This is like a proof. Common denominator of the numerator is cos. So that's going to be cos. Yeah. So I need to make a common denominator of the top because I have 1 minus sine x over cos x. But to put those together, I need a common denominator, which is going to be cosine. So I multiply top and bottom by cosine. Because that's still 1, right? Cos over cos is still 1. So then I got cos minus sine over cosine. All right? What do? Flip and multiply, right? So I get the limit as x goes to the power of 4, cos x minus sine x over cos x. We're really close. What's the problem? Other than it's trig. The signs are switched, right? To make a match, just factor a negative out. It doesn't matter which one you do it out of. You can factor a negative out of this one. If I factor a negative out of the top there, I'm going to get it's going to switch the signs. So I get sine x minus cos x over cos times 1 over sine x minus cos x. And then they go bye-bye. And you're left with we're almost done, Beebles. Negative 1 over cos of x. And then can you plug in pi over 4? Cosine of pi over 4. Which is negative 1 over root 2, which is negative root 2.
The negative, just like this switch to other side. cancel it?
Sorry?
Like you put the negative in there so you can swap the
So the signs switch and then they cancel. Yeah. All right. We'll pick this up tomorrow. Don't worry about doing any homework.